the technology vendors, I think there are a few things which they are very interested into, or which are very, very useful for typical technology vendors. And the most important one is that how you can accelerate your technology development. So it means that CFD can really minimize the time to market. It can significantly reduce the costs which are related to your piloting or your experiments or your technology development. And then it also gives you a huge testing flexibility, which means that you can do all type of configuration testing, different operational testing, like what if scenarios, to really increase the application of your technology. On top of that, in the meantime, it also provides you a lot of insights, which are normally sometimes not possible with experiments or with just measurements. So overall, I think there are a lot of benefits for technology vendors. It saves you cost, time, and also leads to more reliable process performance, and additionally confidence and the new insights. So I will start with one example. So this is, in this case, the client. It's a Japanese client who were modeling, who were actually constructing a pilot for MBR Bioreactor. And they had a very small lab scale bioreactor, which they wanted to scale up to a demonstration scale. So almost 30 times more than their lab scale. So this is a huge transition. It involves a lot of expenditure. If you have to do it stepwise, or have to just build it and then start retrofitting or start optimizing the design. So what we did in the CFD was that we started with a lab scale, validated the CFD model, then we moved to the large scale, and then we tested several configurations to come up with a very good design which will optimally perform. So this design, this CFD modeling actually helped them in saving a lot of time, and there was a drastic reduction in time to market for this technology. In this case, we tested different designs and like around 5 designs in 5 weeks. So this is the order of magnitude we were working in this case. Okay. So this was the final design which was working the best for the client. In this example, this is a prototype of a tubular membrane. In this case, it was very interesting because client already already found out that there is a certain design of the tubular membranes which is working. But what they didn't know why it was really working. So for that reason, we performed CFD simulations and actually figured out that the helical ridges, so these are like very small tubes, like of 4 or 5 millimeter. So helical ridges inside these membranes can really increase the shear stress, which means that it can clean the membranes inside very fast, and it will increase the performance of the membrane. So we can see it on these curves, Riemann open curves, for the shear stress, that the red curve, which is for the helix case, is on the right, which means more shear compared to the plane case, for example. So this was a very interesting study. In this case, we had 3 designs which were tested in 2 weeks, more or less. Okay. So this is another example. It's a novel electrochemical technology. In this case, the idea is that we fluidize the particles using using water. And as you can see that the particles which are sitting at the bottom of a reactor, and if you're pumping some water from the bottom, it will be probably very hard to fluidize them up front. So we started using the CFD modeling for that, and we figured out that if we just go by the general engineering design, we found out that the particles were not really suspending, so they were just falling, as you can see it here. So we tried to make some more changes by adding some design changes, which means, for example, moving the liquid inlet from upwards to downwards, and see if it can help. We went on to make this cleaning, and eventually we got the particles to suspend. But as you can see, that these fluidization of the particles was not very uniform. It was very fast, and every particle was like really going to the top, probably leaving the reactor in relative top. So we further optimized the design, and then you can see now the fluidization of the particle is much more uniform. They are also coming back, and they will keep fluidizing. So this is a very good example where we started from a very basic idea, and then we implemented the whole. So the whole design was really developed in the CFD. In this case, we tested around 6 designs, and it took us around 4 weeks. So in this case, really CFD have been designing technology.